Hello and welcome to this short refresher of number at level 1 and 2 for legacy functional skills. My name is Charmaine Phelps and I'm the curriculum officer for maths functional skills here at NCFE. We have a lot to cover in this session, so if you need to pause the recording at any point, please do so. You may wish to use the video alongside the accompanying activity booklets to check understanding after each section. We're not covering the full curriculum at level 1 and 2, simply parts of the curriculum that Chief Examiner reports have found that learners most struggle with. We'll begin by looking at prior knowledge before moving on to subject content criteria at level 1 and 2, focusing on equivalences between fractions, decimals, and percentages, and we'll end with a short summary. Section 1, prior knowledge. At level 2, learners tend to demonstrate good skills in the use of the 4 operations and can apply these to a range of tasks, according to Chief Examiner reports. However, an area of weakness is due to misconceptions of the underpinning knowledge needed to do calculations involving fractions, decimals, and percentages. So we'll review this now. We'll focus on understanding and using simple fractions and understanding decimals to 2 decimal places in practical contexts. Fractions are always written with one number on top of the other, separated by a line. Fractions help us to understand how many pieces of what size of one whole that we have. So here we have one whole chocolate bar. Here we have one chocolate bar that's been split into 2 pieces of equal size. And the photo shows us one of these pieces. We call this a half. The top number is called the numerator and tells us how many pieces of equal size we're dealing with. The bottom number is called the denominator and tells us how many equal pieces there are. To find a fraction of a number or quantity, you need to divide the number or quantity by the denominator, which is the bottom of the fraction. So for example, we've got these common fractions here. We've got a half, a third, or a quarter. If we wanted to find a half, then in this particular example of the chocolate bar, there's actually 24 pieces. So to find a half, we divide by 2, and we get 12 pieces. To find a third of 24, you would divide by 3. 24 divided by 3, and that gives us 8 pieces. To find a quarter of 24, you divide 24 by 4. That will give you 6 pieces. So if I was to share my bar of chocolate between myself and my 3 daughters equally, we would each get a quarter, or 6 pieces. This is quite a good example to use with learners because you can physically get a chocolate bar and calculate the different fractions that you have of the chocolate bar and enjoy eating it. We're going to look at equivalent fractions. So fractions can look different, but actually mean the same amount. These are called equivalent fractions. So here, I've split the bar into 4 pieces, and this gives me a quarter. A quarter is the same as 2/8. So if I was to split the bar into 8 pieces, they would each look like this. A quarter is the same as 2/8. We can see that because we've got 6 pieces there and we've got 6 pieces there. Or we could say that a quarter, since we have split them down here into individual pieces, a quarter is actually the same as 1, 2, 3, 4, 5, 6, 6 24ths. So these fractions are all equivalent. A decimal shows the number of parts of a whole number. At level 1, learners need to understand numbers to 2 decimal places. At level 2, learners need to understand numbers to 3 decimal places. So The first digit after the decimal place indicates tenths of a whole, and the second value after the decimal place represents hundredths of the whole, and the third digit will represent thousands of the whole. Money is the most common use of numbers to two decimal places from everyday life. So in this example, you can see that we have 3 whole pounds. We have 8/10 of a pound, so that 8 there actually represents 80 pence. And here, the 5, that's 5/100ths of a pound. So that 5 there, 2 decimal places away, represents 5 pence. It is important to recognise that a 0 in a number to 2 decimal places mustn't be ignored. 0 can either be used as a placeholder or it might be a leading 0. So in this example, the 0 indicates that there are 0/10ths of a metre, but there are 5/100ths. So this measurement is 1.05 metres, which is the same as 1 metre and 5 centimetres. I was actually buying new curtains last month, and my daughter read out a measurement that should have been 1 metre and 5 centimetres. But because she ignored the 0 and texted me 1.5 metres, it meant I brought home a curtain pole that was 45 centimetres too long, which obviously wouldn't fit in the space that we had. So it's very important to remember these zeros. In this example, the leading 0 tells us we have 0 whole metres. The digit in the third decimal place indicates that we have 3 thousandths of a metre, 2 thousandths of a metre, sorry, so that's 2 millimetres. So this number, we've got no metres, we've got 89 centimetres, and we've got 2 millimetres, or 0.892 metres. Or we could say, if we multiply by 1,000, it's 892 millimetres. So we'll look at the subject content for level 1 and level 2. So this is the full subject content for number in the legacy functional skills qualification. At level 1 in this recording, we're just going to focus on understanding and use equivalences between common fractions, decimals, and percentages. At level 2, here we have the full subject content, and obviously it's not that the rest of the content isn't important. This is just a refresher session, so we're just going to focus on aspects of the curriculum that learners have most struggled to understand. The assumption is that the full content has already been covered, so the purpose of these recordings is just a bit of a refresher to go over some of the content that learners most struggle with. So at level 2, we're just going to look at understanding and using equivalences between fractions, decimals, and percentages. So equivalences. To find a fraction of a number, you would need to split the number into the number of parts on the bottom. So that's the denominator, and multiply by the number of parts there are. So this is the number at the top, that's the numerator. So in this example, we're looking at finding 3/8 of 100. So we've got our pizza here. Perhaps our pizza costs £1, and we want to calculate how much each individual slice is worth. So to find 3/8 of 100, we divide by the denominator and we multiply by the numerator. So 100 divided by 8 times by 3 gives us 37.5. So we could say that each slice of pizza is 37.5 pence. Dividing and multiplying to find a fraction can be tricky with larger numbers, so it's best to simplify the fraction to make the numbers easier. So in this example, we want to find 8/16 of something. Now, dividing by 16 and then multiplying by 8 is going to be a bit tricky. So to make it easier, we can see that both the numerator and the denominator are divisible by 8. So 8/16 can be simplified to a half. Okay, so 8 divided by 8 is 1. That gives us 1 at the top. And 16 divided by 8 is 2, gives us 2 on the bottom. So 8/16 is equal to a half. And if you think about it like the pizza that's been cut into 16 pieces, if you were to get 8 pieces, then you'd be able to see quite clearly that you've got a half of the pizza. Percent simply means out of 100. Quite often when we calculate percentages, but not always, the numbers will involve money. The percentage symbol means 1/100th. Okay, so that's obviously a fraction, and we already know a little bit about them. So we're on to a good start. So to find 7% of a number, we can see that 7% as a fraction is 7/100. So to find 7% of a number, we can divide by 100 and multiply by 7. Similarly, with 63% as a fraction, this becomes 63/100. So to find 63% of a number, we could divide the number by 100 and multiply by 63. 100% simply means we have all of one thing or a number. So if you were 100% sure about something, it means you're wholly sure, it's complete, you're completely sure. It is possible to calculate a percentage that's greater than 100, but it's important to remember that any percentage over 100 will lead to a number that's larger than the starting number. Now, to change decimals into percentages, we may want to do this because we need to convert a decimal into a percentage in order to calculate a percentage change. We'll take a look at how to do this now, and the subsequent recording, number part B, will show you why it's necessary to be able to do this. So the quick way to change a decimal into a percentage is simply to multiply it by 100. So for example, to write 0.75 as a percentage, we multiply it by 100. So 0.75 times 100 gives you 75%. You must remember to put that percentage symbol. Otherwise, you're thinking of 75 whole numbers. But this percentage symbol shows us that it's 75/100, 75/100ths, which is the same as 0.75. To convert percentages to decimals, this is simply the reverse of what you've just done. You simply divide the percentage by 100. So for example, to change 90% to a decimal, you would work out 90 divided by 100. So 90 divided by 100, if we move the decimal place, move the number 2 spaces to the right, then our decimal place stays the same and we get 0.9. So 90% is the same as 0.9. In the same way, to divide 5% by 100 to make it into a decimal. So 5 divided by 100 equals 0.05. So 5% is the same as 0.05. So to summarize, fractions, decimals, and percentages are simply different ways of writing the same thing. Here are some common fraction, decimal, percentage equivalents that would be quite useful to learn. And I would certainly recommend that when you're dealing with fractions, decimals, and percentages, you deal with real things. Get a pizza, get a chocolate bar, in order to help learners to understand. Get a piece of fabric, measure it, The more practical the examples are, the easier it is to see the equivalence between the fractions, decimals, and percentages. There are some activities on Qual Hub that you'll find in an accompanying bundle for equivalences of fractions, decimals, and percentages to support this recording. Any questions, please contact me, Charmaine Phelps at ncfe.org.uk. Thank you very much for your time, and look out for part B covering percentages and ratio. Thank you.